Unity is a game engine for building 2D and 3D experiences, augmented reality, movies, and other applications. Unity is cross-platform so that applications can be written once and deployed to iOS, Android, web, and other surfaces. Unity has been around for 13 years and has grown in popularity with the rise in gaming and game development. Brett Bibby is a VP of Engineering at Unity, and he joins the show to describe how Unity applications are built. Since Unity SDKs allow for Unity code to run across all the different platforms, from iOS to web to Android to Xbox, this requires writing and maintaining native code libraries for each of these devices. When Asm.js came out, Unity developers were able to deploy 3D games to the web. These were some of the first examples of Asm.js being used. If you remember a few years ago, there were some videos that were trending, or websites that were trending, of 3D games that had been rendered to the web. And that was because of the allowance of Asm.js. Asm.js is a small, performant subset of JavaScript that other languages could compile down to. So in this case, Unity programs in C# were running in the browser after being compiled down into Asm.js. Since then, WebAssembly has improved the toolchain for non-JavaScript code to be compiled down to code that can run on the internet, on the web, I should say. WebAssembly allows for a high-performance compilation path for non-JavaScript programs. After exploring the basics of Unity in today's episode, Brett described how Unity works with WebAssembly and the potential for creative applications of Unity both on and off the web. I should admit, I am very new to discussing Unity and game development in general. These are topics that I have intended to cover for a while, and I'm just starting to get my feet wet, so forgive me if I'm not great at understanding some of the stuff that's going on in the world of Unity and the world of game development, but I will absolutely do my best to cover this material further because I know there's a lot of people that want to hear more about how games are made and how 3D stuff is made, and there's a lot of performance questions around these topics. So I'm looking forward to diving further into these topics, and today's episode is a great example of how deeply technical and certainly different than talking about a microservices architecture or a distributed database or something, which is a lot what we do a lot of shows on, or cryptocurrencies. This is a little bit different territory, and it was fun to discuss it. So I'm looking forward to doing more, and I hope you enjoyed this episode with Brett. I have learned a ton from QCon. QCon San Francisco takes place this year, November 5th through 9th, 2018, and I will be going for my 4th year in a row. I always love going and seeing the talks, and in between the talks, I hang out and eat some mixed nuts, chat with other engineering leadership about the latest talks and stuff that they're seeing, the 50 different stream processing systems that we're seeing, the different databases we're seeing. And QCon is a place where senior software developers and team leaders and managers and senior leaders, they all gather together, and you have fantastic conversations, you have fantastic presentations, and it's extremely high quality. It's technical. A lot of it is also cultural and about management. And you can get $100 off by using the code SED100. QCon is a great learning experience. The presentations this year include 18 editorial tracks with more than 140 speakers from places like Uber, Google, Dropbox, Slack, Twitter. They are curated, high-quality talks, and you can get $100 off if you use code SED100 at checkout for your ticket. Again, QCon San Francisco takes place November 5th through 9th, 2018. And the conference is the 5th through the 7th. November 8th through 9th are the workshops. You can go to QConSF.com to find out more. And thank you to QCon. If you are going to buy a ticket, please use code SED100, and we really appreciate the sponsorship of QCon. Brett Bibby, you are a VP of Engineering at Unity. Welcome to Software Engineering Daily.
Thanks for having me, Jeff. It's great to be here.
Unity is a 3D platform. It supports many different application targets. Explain what Unity does.
Right. So what Unity does in its core is enable rapid development using an extensible editing environment that allows you to build real-time graphics-intense applications like games for the platform of your choice.
How does the usage of Unity vary across different development targets? Because people use it to make games, movies, apps. How does it vary for those different use cases?
Right. Well, it varies a lot. We have in any given 30-day window about 500,000 actively edited projects in Unity. And there is more than 1 million games and apps that have been built and shipped. And those get installed more than 1 billion times every month across the spectrum of platforms. So to say that there are multiple uses is a bit of an understatement. But I do think that what makes it, the core thing that we're solving, the core hard problem that we're solving, is building real-time interactive graphics software is hard. And if you can do that, then it kind of enables other things that maybe aren't quite so hard or adjacent use cases. So I think what we find is that a lot of people come and realize a real-time game engine could be useful for their architectural walkthroughs or visualization or whatever it is they're trying to do. So we see a lot of variance there.
Did Unity start exclusively as a game engine and then other people started picking it up for things like real estate walkthroughs or augmented reality applications?
Yeah, I mean, I wouldn't even say it started out. I would say that we're still, very much focused and centered on the game industry. The game industry is, very much alive and thriving and driving innovation. And when you look at what we're trying to do on the software front and the technology front and to solve hard problems and put this technology in the hands of more creators, you couldn't really ask for a better use case or market than the game market. So I would still say that, we started out trying to make a game and ended up building a great game engine. And that was more than 12 years ago. And, today we're as committed as ever to the game business and the game industry. And of course, we welcome users from all the other use cases as well.
In the process of developing a game, when do I start interfacing with Unity, or what is my interface with Unity? If I'm building, for example, a game on iOS or on a browser, what's my experience of interfacing with Unity?
Right. I think it's more like when you start a project, well, actually, let's get philosophical for a moment, can we? When you think about creativity in general, this always comes as like an exciting insight, right? And it's out of this insight that we see something new. We see something that wasn't seen before. It could be, combining things in different ways, or it could be revolutionary or evolutionary. But there's really something about this creative impulse in human beings in general. And if you think about it, some of the most creative, the creative artifacts that there are in existence in the world, and you think about where those lie, they lie in things like music and writing, and, whether it be sketching, drawing, art. And the reason, if you think about it, it's because you are not between, the idea and the implementation. You're able to rapidly sort of get that out. If you learn to type 100 words per minute, you could start typing a story, and the story could flow. And that flow is what really allows you to stay in that zone of insight and creativity. And it's the same for music. And I think there's a reason why these are some of the most popular forms of creative expression that we have. So, what we look at Unity is kind of the same thing. What you want is a tool that enables that expression, as quickly as possible. It gets out of your way and enables you to do things, in a very fluid and dynamic way. And I wouldn't say we solved all those problems yet, but that's certainly the core of what we're trying to solve. So therefore, when you apply it to your question now about like, how do people approach Unity or how do they get involved in Unity? it's really kind of in this way. A lot of people use Unity because they want to prototype and they have ideas and they need to move fast. And so they come and they start prototyping in Unity. But rather than have to abandon it, Unity can then bring you all the way through production, all the way through, building, shipping, and even running and operating your game. And so I think it's that, the power of Unity is not that we're good at marketing and selling it. I think it's what we're good at is making a tool that empowers people to create, the experiences that they want to create.
So let's say I've got a high level idea for a game where I'm just cat running around an apartment, and that's basically the idea. And so I say I want to just have this cat be able to move around in three-dimensional space, and I want my game to be able to target all these different platforms. I want to have it on iOS, I want to have it on Android, I want to have it on web. What do I start with? Do I start by modeling the cat in some kind of 3D rendering tool, or is there an IDE for Unity developers where I can start developing the cat and developing some code around the movement and stuff? Walk me through the usage there.
Right. And these are two good examples, and they're both true. The saying I like to say, I guess, in this regard is, follow your bliss. So if what came to you was like, oh, there's this cat and I love cats, and I see my cat and my cat loves to, he's very playful and they can move and they can jump, they can reach high places and just, it has so much personality in life, then maybe what I would do is start thinking about, the cat itself and the art and the style of that cat. And maybe it's the animation, or maybe it's that'd be interesting. Maybe I could lay out a 3D space and I could have the cat, get into different places. So, it's not really about the cat and the movement of the cat, but it's the game mechanic. Okay, maybe there's mice that I'm trying to get, but then there's dogs that are trying to get me. And so, I need to be on the floor to get the mice, but then I'm vulnerable from the dog. And therefore I want to outrun the dog. And then a big chase scene could ensue. Oh, okay. So maybe I'd start whiteboxing right inside Unity. We have a tool called Pro Builder. It's kind of like SketchUp. And right there inside the Unity editor, you could start boxing things out. You could, make couches, tables, chairs, counters, beds, dressers, whatever. And then you could create, simple little shapes, a sphere, or maybe a small capsule or something, drop it in, attach a movement controller that, we have samples, stuff like this. And within, 20, 30 minutes, you could be running around sort of a 3D world and interacting with it and starting to develop your behavior, flesh out your ideas. And then, people will start to ping pong. They might start on the art for a while. And then a lot of the stuff that we are, whiteboxing, prototyping. And then let's say you use the Pro Builder tools and you actually saved that locally. We can actually export those as FBX files, which is it's a standard file format that you can open in 3D tools. And then you might go get a tool, whether it be Blender, Maya, Max, or whatever you want to use. You open that asset there, and then you further refine it. So you turn the couch into maybe a nicer looking couch. And when you save that, it pops back up in Unity. So you have this very nice sort of round tripping flow. So when you want to ideate inside Unity, you can do that. And when you want, a more powerful or refined or special purpose tool, then Unity will generally work with that tool as well. So the idea here is follow your bliss, get your idea out there, iterate on it so that you can, what you're looking for is that elusive fun factor.
What about in my browser application or in my iOS application or in my, for example, Xcode, if I'm writing the iOS code to interface with my game, what are the bounds between, and what's the interface between that iOS code and the Unity code?
Right. That's a great question. Well, first, a little bit of context. So Unity runs on, quite a few platforms. We're north of 30 platforms now. And 3 of the platforms are desktop ones, and that's Mac and Windows and Linux support, which is in beta now, but it's coming out soon. And so for every platform, there's a runtime engine. It's a very specially built, highly performant real-time rendering engine. And that rendering engine is embedded inside the Unity editor on desktop platforms. So, you can actually stay right within the Unity editor. You can build, you can press play, and instantly your game will be running and playing inside the editor in real time. And we have, if you put your ultimate build target, like to say iOS, in the game window inside the editor, you can set it for, iPad Pro portrait or landscape. And so you can get really close to what it looks like and will play like on the device itself. And this is, again, part of that rapid iteration. When you're ready to build, or if you want to all the time, when you build, you can output that project as, say, an Xcode project. You can integrate additional code and resources into that project and then do the final build to device and then run it on the device as well. And you can even connect that device back to the editor and do real-time profiling and other things. But the key is this really seamless workflow and round tripping between the editor and the runtime experience.
That those different platform-specific runtimes, so the runtime for the browser and the runtime for the iOS device, for example. Can you tell me about how one of those is designed, and is there a platform team or a set of teams that is responsible for those 30 different surfaces where Unity code can run on?
Yes. And in fact, that's what I think is another really hard problem, is making sure that we can get your content out on those platforms. At Unity, the core engine team, which I lead, is currently about 550 people. And of that, we have more than 120 just focused on platforms, whether it be iOS or PS4, the HoloLens, VR devices, all 30 platforms. And so we have specialists on each platform that basically know the hardware really well, the devices really well, and they're able to sort of bring the Unity runtime engine implementation to those platforms and make sure that they run in an optimal way. So the developers don't have to worry about this. Basically, if you get your experience running inside the Unity editor and press play, and it works the way you want, generally when you build and put it onto the target platform, that's exactly what you're going to get on the target platform as well.
One development that has recently come up that's had overlap with Unity is augmented reality. So Android and iOS both have augmented reality support now. How has that changed the direction of Unity, or has it changed, or do you just think of this as just another vertical or another surface to interface with Unity models?
Right. I think, AR is a bit of a special case. I think AR is really, really, game changing in a lot of ways. I don't think there is no one perfect solution for everything, but I think AR is really interesting because it unlocks things that just weren't possible before. So, while AR is, it's not exactly a platform, and we have AR that you can enable, and we have the AR functionality, and we can get you out using, AR Kit on iOS or AR Core on Android or onto HoloLens or even the Magic Leap 1. So again, our biggest concern is making sure that as a developer trying to build something, that you're able to bring your experience to your customers and your end users. But I do think AR is pretty compelling.
How does AR interface with Unity in a way that is different than previous applications, like building a game on iOS?
Right. Well, I think, like games are already fairly advanced technology, and the, AR is even like farther out on the tip of the spear in that way. So one of the problems that you have with any new emerging technology is lack of standardization. And I think that's good, because we also want to innovate and we want to be able to do, amazing things and support whatever things the platform can do. And so I think the idea is that we've got to achieve two things on that, right? One is we got to make sure that, generally speaking, in AR, you want to track motion or you want to track the environment. Well, we try to make that possible across a variety of hardware, but we also want to allow the platform differentiation to shine through. If you want to target just a single platform and try and take advantage of everything they have to offer, we want to enable that as well. So we consider it like our job just to sort of give everybody the platform they need to innovate and actually change the world with the applications they build.
Backblaze is a company that offers unlimited cloud backup for Macs and PCs. You can use it to back up documents, music, photos, videos, drawings, projects, everything you can think of. It's $5 a month, and you can use Backblaze to access all of your data anywhere in the world, on the web or on the phone. And it gives you the option to restore your files. You can restore files depending on your needs. You can also restore by mail. If you have a complete system failure, Backblaze has a feature where you can buy a hard drive and they put all your data on it and then overnight it via FedEx. Backblaze has restored over 600 petabytes and 30 billion files when people have lost them. So you want to have some kind of backup system in place, or not. Maybe you are the Snapchat generation and you want to just have a Snapchat-like experience for all your files. In that case, Backblaze would not be for you. But if you do not want disappearing files, you can check out backblaze.com/SED. Backblaze gives you a fully featured 15-day free trial at backblaze.com/SED. You can go there and play around with it and protect yourself from potential bad times. Start it today by going to backblaze.com/SED and support Software Engineering Daily. Let's go through another end-to-end example. So if I want to, again, make this 3D cat model, and I want to have the 3D cat model just be running around aimlessly in space, but I want to be able to like hold up my phone and see my living room and just see this three-dimensional cat running around, and the objects are occluded appropriately. So it's, integrating in an AR kind of way. If the cat goes behind a table, I actually see it go behind a table, perhaps. Give me the end-to-end explanation for how I would make this cat model in Unity, and then how I would eventually deploy it to an iOS application.
Right. Well, first, let's go a little bit deeper and just make sure everybody's on board with, let's just answer the question, what is augmented reality? I mean, simply put, it's AR. Augmented reality is the ability to overlay or integrate kind of additional visual media into the view, which then augments the real world. And so how is that done? Well, the core components of AR are really about motion and environment tracking. So in AR, what we need to do is we need some way to find surfaces in the world, like planes, that can be used to build a representation of that space. So we got kind of two things that, terms that we can throw around to do this. The first one is VIO, which is visual inertial odometry, or odometry. And basically what this is doing is combined with plane detection, it's figuring out like where the features are of the world. Another popular term for this is SLAM, which is simultaneous localization and mapping. And so the idea here is you use the VIO and the plane detection, and you identify these feature points. And this is used to then construct primitive shapes of the world. So you might have a couch, and you can find like the cushions, you can find the arms, you can find the front, the top, the sides, the back, and so on. And so once you have that, we can construct an invisible world, or we can construct a world of these shapes. And what we do is when we render, we don't render the shape, but we use that invisible world to basically, we do the positioning, the rotation, the scale, and then we clip the objects appropriately, so that when they appear on screen, they actually look like they're, say, hiding behind the couch and peering out from the back, or sitting on a floor, or sitting on a table. So this idea of SLAM, based on VIO with plane detection, gives some sort of sense to the world. And then, what we're going to do is just integrate a subset of objects that don't fill the whole screen, and then integrate them in space. And to do that, we would use at least a camera. But, that's quite intense visual processing that needs to be done. So the better AR devices also have depth sensors and things like a GPU, a very good, powerful GPU that's able to sort of crunch the data really quickly. So that's your underlying technology that you would need to work with if you want to just go build an AR app natively, even without Unity. These are sort of the pieces involved. So now coming to your example of the cat experience. So you would, in this case, then you would build the cat and the animation, and then you would create the simple state machines. And you can do that right inside Unity with our Mecanum animation system or any other way you want, Timeline or some of the other technologies. And you'd basically say, oh, well, if you give the position of a cat, however far forward you want it to run, you want it to go left, right. If the point is up high, you want it to jump and so on. So now you have the cat, you have the behavior. And now when you integrate it with these other technologies, what's going to happen is you're going to basically generate the environment, the surfaces in the environment at runtime. And then the behavior of your cat interacting with those surfaces will give you the final experience you're looking for.
What's deployed to my iOS device in order to run a Unity model? Is there a software package or some kind of plugin or an agent that is running and dealing with these 3D models?
Yeah, well, so if you wanted to do it yourself, what you would do is you might go I mentioned it before, like ARKit. So if you wanted to put this on iOS, you would go to Apple, you would sign up to be a developer, you would download, all their tools, you would then also get the ARKit. And then you would set about using this kit to, examine the world and create the 3D. But of course, you would still have to turn all that information into a world and put all the behavior and all the other stuff on top. So what Unity does is we basically, in iOS, we work with ARKit. On Android devices, we work with ARCore at Google. If it's Magic Leap, then the Magic Leap 1 SDKs, Microsoft HoloLens, so on. And we also have Vuforia for places where you either want to use Vuforia across the board or you want to get to a platform that isn't a normal AR platform. So what Unity does is then builds APIs, common APIs across all of those devices. So you would only need to target those. You wouldn't actually need to rewrite the code for ARCore and ARKit because we've already done that for you. And then when you hit build, that's what we're doing. We're generating the code using their native SDKs. We put it all together, and then the final compile is done actually by the platform toolchain. So it's basically as if you custom wrote it for each platform, but we're generating all the pieces around that, plus the SDKs and the Unity engine that all get compiled together to get you that end experience.
Let me see if I understand it correctly. The developer develops for Unity, and on the different surfaces, that Unity code compiles down to the native code because there is a common interface on each of these platforms. So the interface is Unity. You write your code for Unity, and on Android, there is some Unity Android SDK, and the Unity code compiles down to Android code using that Unity SDK, and the same is true for iOS or web or all these other surfaces.
That's correct.
Okay. So tell me more about that compilation process and how it varies across different platforms, because in the browser, for example, maybe you have different resource constraints than in iOS, and you have all these different device types that may have different resource constraints. So, perhaps memory management might vary across different platforms, which might give you performance penalties. What are some of the trade-offs that you have to make across those different platforms?
Right. That's a great question. And, I think generally, you called them out, right? The trade-offs are going to be, what kind of CPU, GPU combo do they have? And I think, especially when it comes to mobile, there's one big line, and that is whether it's a GLES2 device or it's a more modern Vulkan device. On the iOS platform, you don't really have to worry about that because iOS has had Metal for some time, and they have GPUs, so you have some compute functionality. But when it comes to the mass market ecosystem, we see from Unity games, 2 billion plays a month is more than 50,000 different models of hardware that are running, Unity content every month. So, the way to think about it really, it's not so much on RAM, it's a factor, but I would actually say it's really down to the GPU. If you have an older GPU running GLES2, the device is going to be a bit more underpowered. That also means its I/O, its ability to load from the file system inside the device. All of that is going to be affected. Its ability to thermal events, when phones get hot, they will actually throttle code, and it will cause your games and apps to stutter and things like that. So these are really critical. Is that you think through the complexity of what you want to build, and what is it about your experience that is most important. Is it graphically rich, turn-based strategy game or a puzzle game? Then maybe it's okay that it's running at 20 frames per second. But if it's an AR or VR, ideally you want that at 120 frames per second or at least 60 frames per second. So you have to think about like what you want the end user experience to be, and then based on that, what you want your reach to be. And then you just got to decide, are you going to target the older devices running like GLES2? Are you going to require compute functionality, which means you're going to need a more modern Android or iOS device, or a desktop with a good GPU in it? And this really dictates then sort of what the range that you're going to be looking for in your content. And then it's really recommended that you just go and build a smoke prototype. You could just say like, oh, in your cat simulation example, you want a really nice looking cat. So maybe you say, oh, I want 10,000 polygons for my cat. Well, you could go and just create a cube with 10,000 polygons, just tessellate it till it gets that much. You could go and look at furniture and other things, and you could just put in a bunch of tessellated cubes that represent sort of the complexity of the environment that you want. You could put different textures on them, and then you could run it on device, and you could look and you could see how many draw calls you're having, how many state changes of materials and other things, what your frame rate is, where it's stalling and where the hiccups are. And you can do that in a matter of hours on day one. And so if you can zero in on that, then you kind of have a good target that you can then decide, I'm going to build for these sets of devices in this sort of range at this level of complexity.
I'd like to move towards talking about the web more specifically and eventually get to WebAssembly. So games on the web have been around for a really long time. Specifically in the browser, what are the concerns that a developer needs to have when developing a 3D game in the browser?
Right. It's a great question. In some ways, I got to say, I wish I had great news for everyone, but it's just, web standards are great, but the web moves really slow and adoption is not like really high. So web browsers, although they follow standards, they basically have different capabilities across the spectrum of devices and OSs. And real-time technologies like WebGL are not everywhere. And so, building an experience that reaches your audience can be challenging. And you really got to be clear on, are you going for desktop? If it's just desktop, then WebGL is quite solid. When you get into mobile devices, phones and tablets, though, the experience can be really uneven. So you have to really think carefully about how you're going to do that. Also, I think it's worth noting that there's an expectation on the web that sites load instantly, and structuring your game and content so that it meets this expectation can be really hard. I mean, we have little images and little bits of text, and we can scroll through and it may look rich and whatever, browsing our friends' photos and whatever, but these are likely JPEGs or PNGs, pretty low quality, and a total web page, maybe a megabyte or 2 megabytes. But if you start, trying to make a graphically rich experience on a high definition display, I mean, it's not uncommon to have 100, 200, 500 megabytes of content in your experience. So, getting that game to load quick so that players think that it's not crashed or something, it can be a bit challenging, just to sort of progressively get people into the game and give it step by step and create all the, the loading, sort of indicators and other things you need, because you have to tolerate really poorly performing devices to high-end devices as well.
There is something called WebGL that I believe it's web graphics library that Unity will target if Unity is having its models translated into a browser-based interface. What is WebGL and how does it work?
Right. So WebGL, it's simply the OpenGL inspired API brought to the web. So instead of OpenGL, you can call it WebGL. And WebGL is great and it's super easy. You can just in a few lines of JavaScript, you can create a triangle or a more sophisticated object. Web is pretty good at loading images and sounds and media and stuff. So on the surface, WebGL is really fantastic. The problem is that even though that there are standards for it, the devices and the OSs cause the browser makers to not be able to support WebGL in the same way on every platform. So even though it's a standard and it is a way to display 3D graphics, and it is on quite a lot of devices, there's still a lot of variance to how the content might look when it's actually rendered.
And how does Unity interact with WebGL?
Right. So what we do is we basically target WebGL by building the Unity engine out through, historically using the Asm.js, which basically gives you the Unity engine, and then translating all of our rendering backend instead of using, Metal or DX12 or Vulkan. We basically target WebGL and then allow that to run there. And it runs quite well. I mean, pretty much anything that you can, like if you're in a browser that's fully supported and has a good WebGL implementation, pretty much anything you can build for, even a PlayStation 4, you could get running in WebGL. But to us, it's just another build target.
Asm.js, if I recall correctly, this was one of the first tools in the evolution of WebAssembly. And what it is basically a set of small JavaScript operations that are highly optimized, and you can compile JavaScript code into, or maybe, I guess you can compile any type of code or any code for which an interpreter to Asm.js has been written. And, for example, you might have C# code and it compiles down into Asm.js, and then it's just a set of JavaScript operations, really small, highly optimized JavaScript operations that can run more efficiently in the browser. Is that right? Is that what Asm.js is?
Yes. And I guess to be clear, let's just drag in the baby with the bathwater here.
Sure.
And contrast that to WebAssembly. So just to be clear, WebAssembly is a binary format for code on web pages compared to JavaScript, which is a text-based language. So just like what you were saying, the Asm.js is essentially very portable because it's actually JavaScript. You load it and it gets compiled on device. So it can go anywhere that there's a valid JavaScript engine. And WebAssembly is essentially the binary version of that. And the thing that's subtle here is that if you had, 10 megabytes of code, you would actually have to download 10 megabytes worth of text files, compile that, using the compiler on the user's device. And that generates another some number of megabytes of actual binary code that it executes. So you need kind of twice as much memory when you're going to work with JavaScript. And so Asm.js was great, allowed us to target JavaScript in a very efficient way, but Asm.js itself needs to be compiled by the JavaScript compiler. So WebAssembly is kind of like a pre-compiled binary version that then the browsers can load and run without needing to download the text files and compile them on the local device.
Before we get to WebAssembly, if we're just talking about the performance advantages you got out of Asm.js, so what were you doing before? Because Asm.js is, in terms of browsers, it's a relatively new technology, even though now it's already getting superseded or supplanted by WebAssembly. So what were you doing with Unity? Like, what was the Unity compilation path for the browser prior to Asm.js, and how much value did you get out of Asm.js?
Right. Well, Asm.js, we wouldn't have been able to even get onto the web without Asm.js. So This goes back to, I guess, like how Unity internally works itself. Unity is structured around the .NET standard. We use a combination. We use Mono in some platforms, and we use the actual Microsoft-supplied .NET toolchain in other platforms. And what's interesting about .NET and the way it works, obviously, is it allows a variety of different languages to interoperate and work together. And the way they do that is, of course, by compiling them to an intermediate format, MSIL, which is the Microsoft Intermediate Language. So the MSIL is essentially, kind of a generic assembly language. It's almost like a generic, virtual machine platform that you target. And then what they do is they take that and they compile that down into native code, which is why it's a bit different than Java is, right? Where Java might leave the code in the intermediate format, and it would compile it dynamically, for the runtime. .NET, this is the standard mode of operation. So what we do at Unity is we use this MSIL as the midpoint, and then we do code generation to convert the MSIL into JavaScript. And then JavaScript can be compiled or to target, I guess in this case, Asm.js with our own .NET runtime, which we also have. So these two things converted and compiled to JavaScript along with Asm.js allowed us to bring the entire Unity engine to the web using WebGL.
Okay, so this is why when Asm.js came out, some of the first videos that people were really excited about were, whoa, I'm playing Doom in the well, I don't know if it's Doom. what were the early? It was like some games, right? Like 3D games, like first-person shooters in the browser, and people were kind of blown away because that was a new thing.
Yeah, exactly. Because you could, it may take a while to load, but out of the box, you could take a large game, a game written for a PS4 or even an iOS, and you could actually build it and get a version out on the web. And this was really exciting because, especially for games that you have to buy, and especially back in the day with premium content, you didn't know if you wanted the game or not. So you could actually take your game, put it out on, say, the Xbox One or the PS4. You could make a small demo version of your game with maybe one level or something, and you could build that and output that onto the web. And people could actually go and experience your game, experience your content directly in the web. And that was really exciting. It's still exciting. We kind of got used to it now. But, to imagine, that we're used to from the old days, HTML1 and simple text to, WordPress and through Facebook and, sort of interactive web apps. But then to really get to like the sky's the limit was and still is, I guess, rather exciting.
Just to go a little bit deeper on the initial compilation path for C# code to Asm.js code, because I believe that was the original path. So you have so C# code. So a Unity application is in C# code, and the on a target like iOS, I believe that the C# code is getting translated via these APIs, like some iOS native API, and on the web it had to get translated through the Unity, or I guess into Asm.js. Gosh, I'm sorry. I guess I'm still a little bit unclear on the compilation path.
Right. First off, it's not just C#, because we actually have we have a bunch of native code in the underlying engine. Matter of fact, our runtime is almost written exclusively in C and C++. So what we do is we actually created a tool chain that's called IL to CPP. And what we do is we take all of the native code as well, and we basically port that over. And then we also take all of the code in your project, the C# code that's in MSIL. We compile MSIL into, using IL to CPP, also into native code. And we're basically then taking full native code pipe, which we would normally pipe into Xcode or the Xbox One compiler or whatever your toolchain is. And we put that into the Asm.js pipeline, and that gets us the JavaScript that we need out the back.
Got it. Okay, so moving into WebAssembly, as you said, the advantage of WebAssembly is that rather than having to have the JavaScript code running through V8, for example, the JavaScript execution engine and having Chrome manage all your hot code paths and whatnot. You compile it directly to WebAssembly, although WebAssembly has to still get compiled into machine code, just like if you compiled, the JavaScript would have to go into a binary, or I guess a bytecode format, then that bytecode format would have to go into machine code. So isn't there still kind of a burden in that compilation process from WebAssembly to machine code?
Yes, this touches on what we were talking about earlier, where generally when you run JavaScript on a device, you're reading in a text file, you're building the binary, then executing that binary. And WebAssembly is just trying to pre-compile that binary for you so that it can run everywhere out of the box. So that means it's smaller and faster to download, and then it's instantly able to execute. We're also missing one piece here that we haven't brought into the story yet, and that is, you were asking about the pipeline, and that's mscripting. So to make this picture really complete, it's core engine code, C, C++, that just comes straight across. Then you have all your project code, which is all the stuff that you've written in C#. That gets compiled to MSIL, the Microsoft Intermediate Language, which is that assembly language intermediate format. And then we use IL to CPP to take that and generate out C++ code. So now we have all C code. We put that into mscripting. Mscripting is the one that actually converts and compiles the C into JavaScript. And that's what that JavaScript plus the Asm.js is what gives you the ability to run in the browsers. And then WebAssembly is just then pre-compiling that kind of like as a library, if you will.
So even in the WebAssembly toolchain, you still have Asm.js. It's just the only difference is WASM does the pre-compilation?
Yes, you still need to do, WebAssembly. You still have to build something for the WebAssembly itself.
Okay. So I think we've laid out a pretty good explanation of the compilation path for WebAssembly, and we've done that also in previous episodes. Let's talk a little bit about the opportunities, because I know we're running out of time. Why is this important? Why is WebAssembly important, and what does it unlock? What does that speed increase, that memory management increase that you get from WebAssembly, what does it unlock for you?
Right. Well, I think what it unlocks for not just us, and obviously all of our customers, is a much more compelling experience on the web, because if a browser is fully WebAssembly compliant, that means that you're not subject to how good of a compiler they have. It means that the code that you're compiling, the code with the optimizations that you want to put in it, fully done, fully ready. So it's faster and easier to download, loads more quickly on the device, and is able to execute without generating, that intermediate representation of a text file, which means less garbage collection, less memory fragmentation, and so on. So I think that, that's good. That smaller code that runs faster is really good. We'd also like to see the multi-threading with web workers become more standard. If we can get that and WebAssembly, I think the web has, I think that will give 3D graphics and even WebGL a little bit more life on the internet as well.
We know that effective learning is active learning. When you master concepts by solving fun and challenging problems yourself, that's active learning. With Brilliant.org, you can actively solve problems and have an interactive experience that can enhance your computer science expertise. Brilliant offers foundational courses in algorithms and artificial neural networks where you can get up to speed on AI. For people with some background in algorithms, there are advanced courses on machine learning and computer memory. Coming soon is an advanced algorithms course which will help you prepare for technical interviews. Go to brilliant.org/sedaily to create an account for free. You need a toolkit and a framework to tackle new problems. Brilliant.org has a well-designed, colorful user interface, and each lesson is packed with guided problems with explanations and interactive quizzes. To support Software Engineering Daily and learn more about Brilliant, go go to brilliant.org/sedaily and sign up for free. Also, the first 200 people that go to brilliant.org/sedaily will get 20% off the annual premium subscription. So if you're like me and you're always looking for new learning materials, especially for complicated subjects like machine learning, then you might enjoy checking out brilliant.org/sedaily. Thank you to Brilliant for being a new sponsor. What about the tooling, the IDEs, the Unity developer experience? That stuff could move to the web as well, right?
It could. I mean, like everyone, it's like if I actually asked you what you really want, would you want a native app that was built natively for the platform that you're running on, that worked in all the exact ways you want with all the, fast frame rates and shortcut keys and configuration, support for various input devices, multiple monitors, multiple windows, touch displays? If you actually think about, what you're going to spend your life doing, you want an expert system, and you don't want an expert system to run on the web. I think it would drive you insane. It's one thing if you're just, if it's, I don't know why it popped in my head, rental cars. So it's like, you go to the rental car counter and, they want to look up your reservation and they've got to capture all the details and get it printed out, whatever. If you think about what that person's job is really providing a service to a customer. And, there's a lot of aspects to that. They're moving around, they're talking to people, the computer is just part of what they're trying to do. But if you imagine that your job was a graphic artist at an ad agency building, magazine ads or retouching photos for 8 solid hours a day, 40 hours a week, you would probably want to kill yourself after a week of trying to use a web version of Photoshop, right? So I think it's, the right tool for the right job.
Just to circle back to what you said earlier about the creativity aspect, I think what makes writing music or creating 3D art with your computer, what makes it a really seamless process is that you get used to that interface and you can directly translate your thoughts through that interface very seamlessly, just like in the past, or still in the present, somebody working with a piano or a paintbrush can have that seamless interaction. Although we haven't really seen a world where that works on a collaborative scale, right? You can imagine a world where you have a collaborative Photoshop or a collaborative music interface. It's hard to imagine that working without having some sort of networked interface, which is obviously a challenge to build, but does seem like a big opportunity that has not really been capitalized or experimented within. Would you agree with that?
I would absolutely agree with that. And I'm not, you got to forgive me for the shameless plug on this, but we just acquired a company called Multiplay in the UK that is fantastic about this. And we believe that this notion of collaboration and client server computing and multiplayer games and all this is very valid. I think this is what we need. I just don't think that, I think the right tool for the right job. I think some parts of what people build and create belong on the web. If I wanted to collaborate with you on writing a script for a game or a film or something like that, we'd be idiots not to use probably Google Docs, right? It's a great way. It's got all the tools that we need for commenting. It's archived, it's backed up, and whatever. But even then, if you were going to get on an airplane, you'd be forgiven if you downloaded it so that you could keep editing it while you're on the plane because you might not have great internet. But, I think you would do that. But if it was like a creative endeavor and, like music and other things, performance is really what you want. And I can imagine going out forward, people taking like game technology and saying, well, gosh, if you can run a massively multiplayer online game with 100,000 players spread out around the globe and in real time with massive amounts of content running around and doing interesting things, then probably we could use that same technology to build, a pretty cool version of multi-user Photoshop or some other collaborative app. And I think, those things are possible today. I'm sure there's other technologies out there, but certainly in Unity, this is something that we care a lot about, is high performance server side, ability to write code, but have it run efficiently so that you don't get hit with compute and other types of charges. And then giving you the ability to create in Unity, you could create even an application. We could create a drawing application and we could put that out on 30 platforms, all speaking to a common back end. And I think there's use cases out there that we haven't even scratched the surface on yet that are going to be really compelling.
Yeah, I completely agree with that. I think it's a frontier, and it's hard to anticipate what shape it will take, what kind of bandwidth we'll need for it, but it's certainly something that we'll see in the future. Better collaboration. I don't think that this siloed, I'm on my laptop and then I need my laptop's performance. It's and you obviously agree. Okay, so we don't need to drum this in, but anyway, interesting thoughts for the future.
There's an interesting thing there though, and that is, because we had a front row seat to the explosion in gaming. And why was that, right? And, I think tools like Unity really enabled people with a vision and an idea to actually build it and get it out there. And what we've seen is an incredible, width, breadth, and depth of diversity of entertainment. Sure, a lot of people are just sitting around, popping bubbles or playing crosswords on their phones as games. But if you look at the crazy amount of artistic drive, the games that have told like amazing stories and just exploded. I mean, 1 million games. And then you got to ask yourself, what's going to happen going forward? Because I believe there's 1 million apps missing from this world. The Photoshop is what, 28 years old today. Or not today, but nowadays is 28 years old. And it was built in a time when people had to put food on the table. So the way you do that in a small market is you got to have a Swiss Army knife. So if you wanted to make icons, you can use Photoshop. If you wanted to retouch wedding photos, you could use Photoshop. If you wanted to, make game textures, you could use Photoshop. But, why not make a custom app for wedding photographers? Maybe it exists, but imagine if I could use machine learning to learn what a bride is, what a groom is, what a church looks like. I've got metadata that I can harvest to figure out where the groom's house was and the time of day and the bride's house and time of day and all these things. I could enable everyone that went to the wedding, as well as the, multiple photographers I had on site, to all upload all the media to a site. And we could use machine learning to grind through all of that, pre-tag and pre-name everything. And then I could go in and say, oh, that's the bride, that's Susan, oh, that's the groom, that's, Bob. And then it starts filling in all the pieces. And then it generates a photo album. It generates a set of wedding videos. It gives you options so that you can say, oh, we suggest this, that, the other. And you could see, oh, I like, sequence A here, B here, and so on. Does automatic red eye removal, does, all the cleanup, does all the tone balancing. I mean, you could build an expert system today, even with a game engine like Unity, that would far surpass your experience with something like Photoshop. Doesn't mean that you would say, I'm not going to use Photoshop anymore. But if you consider, I don't know how many wedding photographers there are in the world, but I'm guessing there are tens of thousands of them. And I'm guessing that a lot of them are constrained by time. You'd probably go and do a wedding shoot on a Saturday, and you've probably got, many, many gigabytes worth of media that you got to sift through. And, you can set up automated workflows and try to cobble together tools. But my point is, there's probably room for an expert system that you could probably charge, $500 a month subscription on, and people would be lined up outside your door to give you that money because, they're time constrained. Instead of one wedding a week, they could do 2. You're talking about actually putting food on the table for people. And how many apps are there in the world that are just missing, that if we were able to rapidly develop them, get them out there, if they were multi-threaded, multi-core, able to use compute, machine learning, client server, ran on multiple devices. I mean, that's transformative. That's world changing. And that's the future that I think is right in front of us right now. An exciting time.
Your mention of Unity there is more in the context of the cross-platform buildability rather than anything relating to 3D, right?
Exactly. I mean, you've got, well, see, there's a thing that we haven't touched on yet, right? And it's like Moore's law, it's done, right? When I'm old enough to say that I came from the 1 megahertz computers, and then it was 2 and 4 and 8 and 16 and on. And then, we had the exciting times when Intel started really going, and we had the 66 megahertz and 256 megahertz. We got to gigahertz and 2 gigahertz and 3 gigahertz and then nothing. And, we're really stuck now on the size that we can make silicon and the speeds that we can bring them at. So what's changed? Well, what's changed is we've got to go wide. Right now, you've got to be able, you've got 8, 16 core, 28 core, processors out there now. And you got to be able to take advantage of those in a very easy way. And I think what's cool about tools like Unity is that out of the box, we can multi-thread all of that. And we can even generate compute and run code on GPU. We interface to things like machine learning. All of these like high-tech tip of the spear innovations that the game industry is using, I think are going to be super useful in the application space as well. I fully can imagine tens of thousands of developers, whether they be enterprise or just, indie developers at home. But, you could build a really amazing app that just, it doesn't do 3D graphics. Maybe it's got some 2D or whatever, but, you don't need those things. But what you actually need is how are you going to write multi-threaded, multi-core, compute-enabled, network-enabled, scalable applications. I mean, that's not super easy to do, but that's what we do in games every day.
Not to open a can of worms, but have you looked at Flutter at all, the Google thing?
Yeah, I mean, I've seen it. I haven't looked deeply into it. Any insights or things you want to share?
We did a couple shows about it. It's certainly very, very early, but as I understand it, it's a compilation path for applications that hits, I guess, the same surface or the same low-level as OpenGL. I don't know much about OpenGL, but I guess it gets compiled directly to ARM code or something like that. I don't know a whole lot about it, but talk to the folks who are working on it. It sounds like a low-level cross-platform target. And anyway, I heard, talking to those people, I heard a similar vision for you shouldn't have to worry about what surface you're deploying to. And I think as this gets taken care of more and more by the compilation paths and the tooling, it will become obvious to people that, okay, so we don't have to worry about whether we're deploying to iOS or Mac OS or the browser or whatever. This is really just a fake concern. I mean, it's a concern right now, but it's not something we should have to be worrying about. And then more people will be thinking, okay, so now that I'm not worried about that, I can think more about machine learning or like how to do collaboration over a network, like effective collaboration in something high dimensional like Photoshop. But anyway, it's a different set of subjects, a lot of subjects.
Yeah, and I do think that, we're going to see more and more of this because we have to. We're going to have to go wide, like I said. But I think that a lot of people believe, it's kind of like the web and mobile. And they think like, web, mobile, and cloud. These three words, you could pepper into a presentation and who knows, maybe even raise a lot of money. But I guess I live in a world where I work my butt off every day. And I don't want to use a mobile phone for 6 hours in a day. And I don't want to use even a web browser for that long. I want an expert tool that I can leverage that works for me. And time is money, and I'm willing to pay for that. So, things like Flutter, I think these are great, but they're very much a mobile first thing. I just checked the webpage here. It's a mobile app SDK. And I think that's great. I think for certain use cases, if you want to find your rental car when you're exiting the airport or the nearest airport lounge or whatever it is, I think that's great. But I think, what I'm thinking is more that massive scale that, like Google Docs itself, right? When Google Docs itself is using things like Flutter or when people move, whole application technologies over, that means it's significant. So it's the right tool for the right job. I think we need stuff like Flutter. I think we need stuff like the web apps and web frameworks. And I also think we need native applications.
Fascinating. Okay, well, Brett, we keep talking for a long time, but really good to have a discussion. Any kind of closing thoughts to wrap together all the disparate subjects we covered?
Jeff, thank you so much for having me. It's great. I love, obviously, spent my life in technology and love it, super passionate about it. What I always like to tell people, if I have any advice for them, and that is, follow your bliss. There's just a real joy in making stuff, whether, some people are into food, some people work with wood, some people make all kinds of arts and crafts. And of course, in my industry, we make a lot of games. But, there's just a real joy from making stuff. And when you make space for that insight and creativity, that's reflected in your end products. And that's understood by human beings universally. When we hear an amazing song or, we see or read something amazing, it's universally known that it's amazing. So, bring that to your craft and building whatever you build. And if it's games, certainly do that. And you won't get lost along the way.
I couldn't agree more with that. I think it can be an immense therapy to create something and to be able to, just to riff a little bit on that, it can be slightly narcissistic in some ways to have artifacts of your creativity and to revisit those artifacts over time. But I find it, personally, whether it's making podcasts or art or music, whatever, making stuff and then being able to look back on those things and say, yeah, I made that, and also I've had progress over time, and the things that I create, it brings me, like you said, that term bliss, it brings me such satisfaction that it just makes me want to do more of it. And it seems like a one very healthy addiction or feedback loop to have in my life.
Couldn't agree with you more.
Okay, Brett, well, really good to talk, and thanks for coming on the show.
Thanks, Jeff.
Leap.ai matches you with high-quality career opportunities. You are more than just your skills and a job description and a resume. These things can't fully capture who you are. Leap.ai looks beyond these details to attempt to match you with just the right opportunities. You can see it for yourself at leap.ai/SEDaily. Searching for a job is frustrating, and Leap tries to reduce the job search from an endless amount of hours, days, weeks, to as little as 30 seconds, trying to get you matched to a job instantly by signing up based on your interests, your skills, and your passions. Leap works with top companies in the Bay Area, unicorns and baby unicorns, just to name a few: Zoom, Uber, Pony.ai, Cloudera, Malwarebytes, and Evernote. With Leap, you are guaranteed high response and interview rates. You can save time by getting direct referrals and guaranteed interviews through Leap.ai. Get matched to jobs based on your interests, your skills, and your passions instantly when you sign up. Try it today by going to leap.ai/SEDaily. You would also support Software Engineering Daily while looking for a job. Go to leap.ai/SEDaily. Thank you to Leap.ai.
Wow.